Here we've got some questions and we're going to go straight to the calculator. So, the results for a maths exam are normally distributed with a mean of 60, a standard deviation of 8. And we know it's normally distributed, so let's go to statistics, calc, distribution, and normal cumulative distribution. Now let's have a look. Find the proportion of students who passed. For that, I'm going to assume that the mark was 50% or above. Which means that for A part 1, I'm going to say that my lower value equals 50, my upper actually equals infinity. And we need to keep that in mind. Not 100, we need to make sure for the normal distribution, if we're ever looking for below or above a value, that we use infinity. Now, this is why it's important to list our values, because if we got the wrong number here, and the examiner was suggesting that a pass mark should be 40, and we can see that it's the interpretation of the question, and we've interpreted the question reasonably, we're going to get the marks here. So, my lower is 50%. My upper is infinity, so remember we're going to hit the keyboard, Maths 2, infinity. My standard deviation is 8, and my mean is 60, and we can find that 89.435% of people passed. So what I'm going to say here is the probability that x is greater than 50 equals 0.894350. And then what I would normally write is, and remember a lot of these questions are asking to 4 decimal places, so I'd write 0.8944 to 4 decimal places. So then we can see that I've read the question and I've answered it appropriately. Part 2 asks for a score above 80. Exactly the same idea here. My lower is going to be 80, my upper is going to be infinity. I'll go back a step. All I need to do is change this to 80 and hit next, and I find that this funny number, which means 6.2097 times 10 to the minus 3 equals 6.2097 times 10 to the negative 3, which equals 0.006297, which is 0.0062 to 4 decimal places. And there's my answer for part 2. Time now for part B. Part B is asking, what's the probability a student has scored above 70 given she passed? So that's saying, what's the probability that the score is above 70 given the score is above 50? Which means the top line should be the probability that the score is above 70 and the score is above 50 over the probability that the score is above 50. Now, if my score is above 70, it will be above 50. So ultimately, we can ignore this part. And my actual answer will be the probability that my score is above 70 over the probability that the score is above 50. So I'll put that into the calculator. I'll go back a step. My lower boundary will be 70, my upper infinity, and I get a value of 0.10565. So I'm going to write that 0.1056. Let's get it to all its places. 498 over my probability that x is above 50. I found that out here, and I cunningly kept all my values, so I can write 0.894350. And let us put that into our main part of the calculator. So 0.1056498 divided by 0.894350. Remembering our answer must be between 0 and 1 if we haven't made a mistake, and we get 0.1181. So I'll write that down now, 0.1181, and there's my probability for part B. So now let's go to part C. Part C is a little bit different because what I have to do is consider that my normal curve looks like this, and that we're looking for the top 10% of students. So here's my score, and underneath here, this is where an area is 0.1 or 10%. Remembering my question tells me that my mean is 60 and my standard deviation is 8. So let's write the mean 60, the standard deviation is 8. I can use the calculator to find this out. And what I'm going to do is I'm going to use a function called the inverse distribution. So let's go to that. We're going to go Menu, Statistics, Calc, Inverse distribution here, not normal distribution, and we are using the normal. Then we're going to say, because my tail here is to the right, you can see here my value of 0.1 is going to the right, I'm going to set this, the tail setting, to the right. My probability I'm not sure of. My standard deviation is 8. My mean is 60. I beg your pardon, my probability, I have 0.1 here, so 10% of my students are in this area. This is what goes into my probability space, 0.1. Let's try and get that in there now. 0.1, and I hit next, and it tells me that my score that I would have needed here is 70.25. So to be in the top 10%, I need a score of 70.25. So what I'm going to write here is prob equals 0.1, tail equals right. I know the mean and the standard deviation, therefore the score x equals 70.25%. So I could say now a student requires 70.25% to get a prize. And my examiner will be delighted with my work.